Question: what is AWS Elastic Load Balancer and how does it distribute traffic? Answer: AWS Elastic Load Balancer (ELB) is a managed load balancing service provided by Amazon Web Services (AWS). It helps distribute incoming applications or network traffic across multiple resources such as Amazon EC2 instances, containers, or IP addresses to improve availability, scalability, and fault tolerance. There are three types of elastic load balancers in AWS. Number 1. Classic Load Balancer (CLB). The Classic Load Balancer is the original load balancer service provided by AWS. It operates at the transport layer 4 of OSI model and distributes traffic based on information from transport layer protocols like TCP and SSL. Number 2. Application Load Balancer (ALB). The Application Load Balancer operates at the application layer 7 of the OSI model. It can intelligently route traffic based on content-based routing rules such as URL path, HTTP headers, or request parameters. ALB supports advanced features like host-based routing, path-based routing, and integration with AWS services like AWS Web Application Firewalls for enhanced security. Number 3. Network Load Balancer (NLB). The Network Load Balancer is designed to handle extremely high volumes of traffic and provide ultra-low latency. It operates at the connection level layer 4 and routes traffic based on IP address and port. NLB is often used for protocols that require high throughput such as TCP, UDP, and transport layer security (TLS). Here's how the Elastic Load Balancer distributes traffic. Number 1. Health checks. Elastic Load Balancer periodically checks the health of the registered resources by sending health check requests. It ensures that only healthy resources receive traffic. If a resource fails the health check, the load balancer automatically routes the traffic away from that resource until it becomes healthy again. Number 2. Availability zones. Elastic Load Balancer can distribute traffic across multiple availability zones within a region. Availability zones are physically separate data centers with independent power, cooling, and networking. By distributing resources across multiple zones, the load balancer can provide high availability and fault tolerance. If a zone becomes unavailable, the load balancer automatically routes traffic to the available zone. Number 3. Load balancing algorithm. Elastic load balancers use various load balancing algorithms to distribute traffic every across the registered resources. The algorithms include round robin, least connections, and IP hash. These algorithms consider factors such as the number of connections, the size of instances, and the health of resources to make load balancing decisions. Number 4. Sticky sessions. Elastic Load Balancer supports sticky sessions, also known as session affinity. With sticky sessions, the load balancer routes requests from a particular client to the same registered resource for the duration of the session. This is useful for maintaining session state in applications that require it. Number 5. SSL TLS termination. Elastic Load Balancer can terminate SSL TLS connections on behalf of the registered resources. It can offload the SSL TLS encryption and decryption process, reducing the computer computational load on the resources. The load balancer can also handle SSL certificates and negotiate secure connections with clients. Number 6. Scalability and auto scaling. Elastic Load Balancer works seamlessly with AWS auto scaling as the demand on the application increases or decreases. Auto scaling can automatically adjust the number of instances behind the load balancer to meet the traffic requirements. This ensures that the application can scale dynamically to handle varying load conditions. By using Elastic Load Balancer, you can achieve improved fault tolerance, scalability, and availability for your applications. It helps distribute traffic across multiple resources, ensures high availability by monitoring resource health, and provides advanced features for content-based routing and SSL TLS termination. Thank you.